Hey guys, it's Bill from Linden, Tennessee. Gonna have a little update video. Not a whole lot of extra content in this, but I just wanted to put something together real quick. Um, so I've wanted to put power onto the drive unit. There's a Wi-Fi app that you go on there and you can adjust all the settings and stuff. So I turned the key on and got my voltmeter out and checked the little amp seal connector at the motor and found that I did not have voltage. So I backtracked into the original fuse block from the Jeep, and so this fuse right here, it's labeled BMS. It is the sort of key switch ignition fuse, and it provides power to the drive unit, and it also gives 12 volts to the DC-DC converter to get that thing going. That way when you got the key off, the DC-DC isn't just constantly running. That's how I had my Ranger set up, but the Ranger didn't have its own 12-volt battery, so that's how it had to be. The little EVIC display actually pulls a small amount of current because it's got a hot at all times input to it, so it pulls a little bit of current from the 12-volt battery. So if I ever finish this and I drive it and then I have to park it for a little while, I'm going to need to disconnect the 12-volt because it will slowly drain itself. Anyway, so I looked at that, and that relay wasn't clicking when I turned the ignition on. So I looked at the wiring diagram that I had drawn up for this. It's on my computer. I just did it in Paint. Maybe one of these days I'll figure out how to edit in a picture on top of a video and show you how that is. But anyway, discovered that my wiring, I didn't have a ground for the relay. It's like, anyway, dumb accident. So I went back in there and went into all this, and it turned out to be a combination of this wire here, and I think it was this one here. That was my ground. So that's now going to the relay for the ground, and then this is the output. The green one is going to the DC-DC, and then the pink one there goes to the drive unit. Yeah, so got that fixed and sent power to it. Got the drive unit to come on, and my computer identified the Wi-Fi present. I put in the secret squirrel passcode, and lo and behold, it came up, and a whole bunch of you can go with the password that I have. I can go into tier 1 adjusting of the settings for the inverter, and there's a list of them that I can't even begin to guess what they are. KP, and there's like UDC and UDCSW, and there's like I don't know, there's probably 20 different settings. I'll do a screen capture walk through whenever I actually set these things up. But I need to go into town and pull up the internets and see if I can't figure out what all those settings are, and maybe try and figure out how to adjust them. So yeah, that's that. And then I also discovered that pin number 2 on the drive unit is it's for brake switch. Now I thought that was an output from the inverter that would go to a relay to make the brake lights come on whenever you're under heavy regen. But no, that's a brake input. So that 12 volts goes into that whenever the brakes are applied. So you have to push the brake on, I think. You have to push the brake on, and then you can select drive or reverse, and then you can go. So that's actually an input. So this relay back here, that in there, which is normally hidden behind the charger, DC-DC charger, I had that wired up wrong too. So I had that wired up so that what I thought was a ground coming from the inverter would go to that, energize the relay, and then provide power to the brake lights. But instead, that wire from the inverter needs to have 12 volts going to it from the brake lights whenever they're applied. So that was actually a pretty easy fix. I just took the wire that I had going to the brake lights and spliced it with the wire going to the inverter. So now anytime you push the brake, that inverter wire is energized. Then I took another wire and ran it from the ground side of the the well, the ground side of the relay, gosh, not the output, but the input, coil. So the ground side of the coil, and that's going to go to JLD 404, my favorite gauge, which I hadn't really intended on putting in this build, but I'm happy to add it to the build because I really like that gauge. I always have. So that'll be a ground input whenever the JLD detects so much negative amperage coming in from regen. It'll ground that wire out, and this relay will turn the brake lights on. So that was an easy fix. So that's good. And then, what else did I do? Then, since I'm now, my mess. So this is my contactor box. I started wiring it up. On the right side is the most positive contactor, I guess you'd say. It's the contactor with the pre-charge circuit on it. On the left side is the most negative contactor. So the most negative battery cable will come through that inductive amperage pickup and land on the contactor. Then that contactor will be controlled by the BMS, and it'll be the it'll be the discharge enable contactor. So anytime you need to put a load on the 400 volt pack, the BMS will determine if that's okay or not, and connect that contactor, and then current can flow through that contactor to a negative 400 volt terminal block that I got there, and then from that terminal block we'll go into these fuses, battery heater, cabin heater, or whatever, any kind of 400 volt load, and allow that to work. So that's good. Shoot, where was I going with all this? Well, I wish I could back up a little bit and remember what I was just saying, but I don't remember what I was just saying. Well, yeah, the power for the pre-charge contactor and the main contactor. That's actually 4 wires that come out of the inverter. They go to there. Now, originally, I had planned on all of this contactor box being in the back. So I had all my wires for the contactor coming up over here, waiting for me to, connect it add it into this wiring harness and run it to the back. But I'm not going to do that anymore, so I had to kind of take my whole wiring harness apart and pull those 4 wires out, because now they're going to run into one of those bottom 3 openings and into the contactor box. So I've done that. And then the next thing I want to do today is I need to make a fiberglass cover. I'd like to do a metal cover, a sheet metal cover for this, but there's a lot of compound curves and just it's outside my pay grade to do that. I'd like to someday learn how to do metal shaping, but it's not going to be this day. So I'm just going to make a real quick fiberglass mold sort of cover, and then what that'll do is I'll have holes drilled in the fiberglass cover roughly about right here, because my battery management box, which is mounted, it's bolted to a plate. You probably can't see it, but it's bolted to the plate that bolts to the top of the contactor box. And then all these doggone wires, these ones are the ones that go to the front battery box. So I've got all my cell taps right there. There's 3 sets of 12 from the first part, and then another set of 12 from the second part. So because I got 48 cells in the front that need to be monitored. So those are all going to go to the front, and then I've got, I'm only going to take one of the thermistors from each of the batteries. There's 2 thermistors per battery module, but I'm only going to take one because, I don't know, in my brain anyway, the first thermistor and the second thermistor have got to be relatively the same temperature. I don't know. I'll try and make it so that the thermistors that I choose are on the outlet side of the coolant. I don't know. Anyway, so that's what I've chosen to do. I hope it's a good idea. So, yeah, that's that. And then this gland nut will go in to my fiberglass cover. And then the fiberglass cover will have like a U shape cut out of it. So whenever the cover's on there, the gland nut's on there, and it kind of looks like it's supposed to be there. But if I ever need to take the motor down, then I can loosen the gland nut, take the fiberglass cover off, and then have access to put that chain in there and lower the thing. So goes the theory. And then what I hope to do after I've done all that, if I get all that done today, is drop this rear battery box down and try and finish it so that I can either send it to powder coating or just spray bed liner all over it. I don't know. I want kind of a durable finish on it, but I don't know. I'll decide later. But that's my plan, to have that all finished up, and then I can get it painted or whatever, and then put the batteries in it and run all the coolant and run all the BMS taps, cell taps to it, and install it for good. That will be nice to have one battery box installed for good. But I got to get it started. So that's that. And then after that, I'll move to the rear battery box, which I haven't even taken an aggressive look at. I need to cut all these extra all thread off and put the sides on. And I got to do, well, basically I have to do everything to this one. And then this is easy though. The mounts on this will be really simple. I think this whole thing's going to get scooted up to roughly right there, or to the front of this. It's probably going to get scooted up to there, and then it'll be shifted over sort of away from us in this view. And then my shunt for the JLD, and then a fuse, and then a master disconnect will go between the tank battery box and this battery box. Ideally, I'd like to have it center pack, but ultimately it doesn't really matter. And with the BMS2, the Orion BMS, you have to put any fuses or disconnect or anything between cell groups. So that's the first cell group that's split, that I had to take part of the full cell group 1 goes to the front battery box. One of the parts of cell group 2 goes to the front battery box. The other 2 parts of cell group 2 goes to the tank box, and then the third cell group will go to the box that's here in the bed of the Jeep. So I can put fuses and disconnects between these 2 cell groups. That's how it works. That sounds really confusing to you if you don't know what I'm talking about. Sorry. It is confusing. So, and then finally, once I've dealt with all the wiring that I was talking about earlier, what I did was I made myself some little connectors. I just got some NPT connectors here and a barb fitting that will go into my 3/4 inch hose here. So 3/4 inch barb fitting going into an NPT. Welded that to a little bracket that I welded to my mounting bracket for the charger, and then got an AN fitting and welded that to the bottom of it. So yeah, so coolant's going to come in through here, going to fill up the bottom first, go up through all the stuff, and then come out here, and then go back down, and then go into the coolant system. It'll come from the motor inverter, come from the motor into here, go through the charger, and then come out, and then go into the radiator. Yep, that's that. So that'll get thrown back up in there, and that's going to be a pretty busy day. I doubt that I'll get all that done today, but I made a list, so it's more likely that I will. All right, guys, that is it for this time. Thanks for watching. Stay tuned.